In this segment, we're going to continue talking about addition of proper fractions, except this time we're going to be working with common denominators and different denominators, but my sum is going to be greater than 1. So how do we handle that with a manipulative? So the question we're going to work with is 3/4 plus 3/4. They both have common denominators of quarters, but we should get an answer bigger than 1. So we're going to use this double pink to make is going to be our 1, and therefore this is going to be a quarter then, and so we're going to fill it in for 3/4. And so there's our quarters, 1, 2, 3, 4 quarters. We've got 3 of them, so we've got 3 of the reds. So there's our 3/4. We do the same thing again. And there's our question with our fraction blocks. 3/4 plus 3/4, and what are we going to end up getting? Well, we're going to get 1, 2, 3, 4, 5, 6 quarters. And we could leave that as an improper fraction, producing 6/4, but we want to change that into a mixed fraction, and then we're back to what we were talking about, how to change improper fractions to mixed fractions. So it would look something like this. I take this piece here, and I turn it around, and I can stick it into this one now. So now I've produced 1 whole and 1 out of 2, which is 1/2. So I've got 1 whole plus 1/2. And it could look something like that. Now some students would say, if I have 6 quarters, it's going to take 4 quarters to make a whole, and I'll have 2 quarters left over. And then we want to make sure that we reduce our fraction to the lowest term, so we divide it by our magic 1. And so I divide by my magic 1, and I get 1 and 1/2. So again, making sure that we can see that we can show it 1 and 1/2 in a couple of different ways. We can go 1 and 2/4. Our 2/4 can be reduced to 1 and 1/2. Or we have 1 whole and 1/2 of the other one. There's a couple of different ways I can show the pictorial version of it. So if I take a look at my 1 by 1 box here, and I've cut this one into 3/4. So I take my 3/4 and I shade in 3 of the 4 regions. And I start in shading 1 of the 4 regions, and I just duplicate it. And so there's my first 3/4. And now from here I can do it a couple different ways. I can add my 3/4 over here on the right hand side, or I can start adding 3/4 where I left off here, but I'll put it into separate just so to keep them separate for now. And there's my other 3/4. So I have a yellow 3/4 and a green 3/4, and I add them up. I get 1, 2, 3, 4, 5, 6. There's my 6/4, which is what I have here. And if I want to change it into my mixed fraction, what I can do is I can take this over and I can fill that one up. So now I have 1 full one. So there's 1 whole and 2/4, or 1 and 1/2. The other way I can do it is do it all with 1 square. So there's my 1 by 1 box again. I want to shade it into 3/4 and 3/4, so I do it in 2 different sections. One's going to go vertically and one's going to go horizontally. And it might look something like this. So I've got my 3/4 going vertically, 1, 2, and 3. And I've got my 3/4 going horizontally, 1, 2, and 3. And again, I count the single markings, or single shaded, 1, 2, 3, 4, 5, 6. But as I've shown before, each of these has a yellow and a blue. That's why they've changed color. So I'm going to count these twice. For a total of 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 21, 22, 23, 24. I've got 24 out of a possible how many pieces? Out of a total 4 by 4, which is 16 pieces. So I've got 24 out of 16. 24 out of 16 is bigger than 1, so I can fill up 1 by going 16/16. So I have my 16/16. That leaves me with 8/16 left over, for a total of 24. My 16/16 is 1 whole, and my 8/16, if I divide by my magic 1 of 8 over 8, gives me 1/2. So I can get my answer of 1 and 1/2 using this technique as well. In this next question, we're going to go 4, 6 plus 3/4. We could spend a moment again talking about, is my answer reasonable? What would be a reasonable answer? 4/6 is over half. 3/4 is over half. So I would expect to get over 1. But 4/6 isn't at 1, and 3/4 isn't at 1. So 1 plus 1 would be 2. So my answer should be somewhere bigger than 1, but less than 2. That would be a range that we could look at. If we're using our pattern blocks, this is our whole, then 4/6 might look something like this. Each of these being, it takes 6 of these to make a whole double pink, and so therefore I have each of these blues are called 6, and I have 1, 2, 3, 4, so that would be 4/6. And to that I have to add 3/4, so there's 1, 2, 3 out of my possible 4, so there's my 4/6 plus my 3/4. And I think just by looking at this we can see that we're going to have enough to fill up a whole double pink, so we're going to get an answer more than 1, and we're going to talk about how to do that in just a sec. As it stands right now, we can't add them together because they're two different colors, they're two different shapes, and so therefore we only add things that are the same. So it would be really nice if we can convert them into one or the other. And if I could take these, I've got one pair there, and I got another pair here, and another pair here, and then I've got a pair here, but I'm going to have one sticking out on the end. So changing everything over to blues isn't going to work. So I can't make that a common denominator. Is there another shape that works for all of the blues and for the reds? And we can see that the green shape's going to work. So I'm going to change those all into green shapes. So as we can see, I can take all my blues and cover them completely with my greens. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of the greens. And each of the greens is a 12th because it takes 12 greens to cover my double pink. So I've got 17 twelfths. And so there's my answer as an improper fraction. Now I want to see if I have enough to make a whole, and I do. I could take this one and slide it over here, this one slide it in there, this one and slide it into here, and this one and slide it into there. So now I have one whole and 1, 2, 3, 4, 5 twelfths left over. And so it could look something like that. So there it is with our manipulatives. Now we want to make the connection between the symbolic. So what steps would we ask the student to show if we were asking this question, 4/6 plus 3/4? We'd want to show them changing it to a common denominator. So our common denominator between 6 and 4, the smallest one we would pick would be 12s. We could change it to 24ths, but we'd have to do some reducing. So we want to change it to 12ths. So we know that 1, 2, 3, 4, 5, 6, 7, 8, 8 twelfths is the same thing as my 4 blue sixths. And I would show that using my multiplying by my magic 1. And again, I just call it the magic 1 because it has so many magical things that it can do. And why are we choosing 2 over 2? Because it takes 2 greens to make my blue. And that's what I'm changing. I'm changing my blues into greens. So it takes 2 greens to make a blue. So that's why I'm choosing that magic 1. And over here, I'm going to change my 3/4 into 9 twelfths because my 3/4 are my 3 reds, and I'm changing that into 9 greens. And so we show some work like this. And again, why do I choose 3 over 3? Well, to make a red requires 3 greens to make every red, and that's why I chose that magic 1. I want to change my reds, which are fourths, into greens, and there's 3 greens for every red, so I'm using that magic 1, so I get 9 twelfths. 8 twelfths plus 9 twelfths are now the same thing. I get my 17 twelfths, and then I can convert that to 1 and 5 twelfths. Using the Cuisenaire rod to show the same thing, 4/6. My green rod is 6 whites long, so I've got 4 out of my 6. My pink is 4 across, so I've got 3 out of my 4, and I want to add those together. The greens and the pinks are not the same length, so I have to change them into something that's equivalent. And again, working with our multiples idea, I notice that it takes 2 greens to be the same as 3 purples or pinks, and therefore I'm going to have to double up what I had here, and I have to triple up what I had here. So what I've done is I've taken my 4/6, and I needed 2 of them, so I just doubled all of this together, and I've done it twice. 3/4, it's taken 3 of these to make the same length, so I've just taken this and done it 3 times in a row. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 of something. And what is this something that we have? Well, 2 6s is 12, and 3 4s is 12. So I've got 8 twelfths and I've got my 9/12, which is what I had before when I did it the other way. And together now I've got 12, so I can add them together to get 17/12, which is enough to make one whole with 5 left over. And that might be the work that we want to show for that. My 8/12 for the greens, my 9/12 for the pinks, together gives me 17/12, which is 1 5/12. And again, to show that 17/12 is 1 5/12, I've got 1, 2, 3, 4, and if I just move these, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12. So there's my 12/12s making my one whole, and I would have 1, 2, 3, 4, 5 12s left over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My 12/12s makes up my one whole, and I have 5 12s left over. 17/12 is the same as 1 5/12. So in this segment we've talked about multiple ways of adding up fractions to produce an answer bigger than 1, and how we can show how we can regroup that to get a mixed fraction.